Hello, everyone, and welcome to the first Datamine laboratory webinar in North America. This one is titled Samples and Data All Matter, Geochemist Journey. My name is Alex Kawabe. I am the project director here in North America and former ASENET general manager. Here with me is Alan Cohen, senior laboratory advisor. Let me briefly do a brief introduction of Datamine. Datamine offers a comprehensive suite of solutions that spans the entire mining value chain with specialized technology supporting exploration, geological modeling, and mine planning. Datamine also delivers targeted solutions for mine production, laboratories, and environmental, social, and governance, also known as ESG, aspects of the mining industry. In the labs space, we have two solutions, C-Class and ASENET. Both solutions, both LIMS solutions, focus on the laboratory workflow rather than just sample management. And as far as North America, the preferred solution is ASENET, since the team is here in Canada. Now, without any more delays, let me pass the mic to Alan to introduce himself and start with the presentation.
Thank you, Alex. So who am I, and why am I here? Great question. I'm a chemist originally. Switched ironically to geology because I thought I didn't want to be stuck in the lab, and I've spent my entire career actually excelling in the laboratory space. So obviously this is where I'm comfortable. But I'm a geochemist, combining both the skill set of the chemist, the tinkerer, the instrumentalist. I love the instrumentation and applying the instrumentation to solving geological and geochemical problems. This is really what I enjoy doing. This is what I've spent most of my career doing. I do have a master's degree in geochemistry from Colorado State University. I'm currently located in Denver, Colorado right now. And I've been involved in a variety of exciting applications, both in the traditional bulk chemical space, as well as some of the high-tech microanalytical space. I mentioned here some of my background with regards to laser ablation, ICP-MS, really the microanalytical, where does the chemistry live in our rocks? And that's something that's really been exciting for me to have been involved in a wide variety of interesting applications, not just in geochemistry, but I've worked in biological sciences, solving problems using the laboratory instrumentation us geochemists have been so good at developing. I spent most of my career at the U.S. Geological Survey here in Denver, running the laser ablation and other microanalytical and geochemical laboratories here at the USGS Mineral Resources Program in Denver. So almost 2 decades of my career has been in that arena. Again, applying laser ablation to a wide variety of mineral resources problems, geochemistry, classic geochemistry problems, as well as fish ear bones and drug trials, prostate cancer research, really using the tools that us geochemists have developed, us geologists have developed as really mineral detectives or chemical detectives. And it's been a huge honor to be involved in so many great diverse applications. I've bounced around to a few instrument companies. I do really enjoy the instrumentation development. And as you see here on the slide, I have several stints at instrument companies, both early in my career and most recently with a laser spectroscopy company. And then after that little adventure, I ended up at a large global mining company, being not only lab manager, but also global technical advisor for analytical geochemistry, solving some lab problems for global mining labs. So I've seen a wide range of lab types and wide range of problems. I know a lot about how to and how not to run geochemistry labs, and this is what I really enjoy talking about. My role right now as a consultant is just applying those skills that I've learned over my career to a wide variety of labs. So, some of the things that I'd like to talk about today is where does the lab sit in this mining food chain in the ecosystem of the mining space? A lot of times, the labs are treated as a separate entity and not seen as in its true form as how critical it is to the entire lab ecosystem. And this is a slab that this is a slide that Dion from Datamine has used in the past, showing that the lab really does sit at the intersection of many of the parts of the workflow for the mining community. And I think this is a really important reminder that we actually need the labs to solve a lot of our problems, but the lab also sits as an expert in this nexus between these various forms of the lab. What I'm going to talk today about is not just the on-site mining labs, but the role of the central labs, these external labs, whether they be commercial labs or the actual on-site labs. And I think this is something that we probably need to spend a little bit of time as a community thinking about, is how to better utilize our lab information in this greater ecosystem. I think that's a lot of opportunity for improvement. A lot of times these labs have morphed into just get it done. They were not. They're doing things that they weren't originally designed for. A lot of times the labs aren't forward thinking in terms of future projects. We do what we need to get by. And again, I think I see a lot of opportunity for redesigning the space that the lab exists in and contributes to this greater workflow. In terms of mining site labs, oftentimes we don't have that extra capacity to answer extra questions. We're just barely trying to keep above water on ore control related samples. But in many cases, these labs do have the opportunity to contribute in these other areas. So it'd be great if we did have that extra capacity. So these are some of the topics that I've talked a lot about just in my career. Just the labs aren't these black boxes that just generate numbers. And I think this graphic represents my view of sometimes how labs are, created as islands or morphed into these islands. Where, as you can see in the figure, we do have parts of the mine throwing rocks at the lab, and maybe they're doing their work in a vacuum. They may be experts on the samples they get thrown at, but maybe people aren't asking them for their feedback on some of the information. In some cases, and this relates to the data part, the software part of the whole story. In many cases, we're using technology not much more advanced than carrier pigeons carrying napkins with data written on it back to our customers. And so this full ecosystem, this interplay between the labs, the rocks that are being thrown over the fence at the lab, and the data that comes out of the lab is an area that we actually have a huge opportunity to improve the workflow. I even pick on the fact that we refer to these labs, these laboratory information systems, LIMS, as a term, maybe is a little bit misleading, because it's more than laboratory information. It's sample information. These samples that are being hurled over the fence to the lab actually do represent huge value of sample information. Where did it come from in the mine or the exploration process? What information do we have as geologists, metallurgists, mining engineers about the sample that would be useful to connect not just the lab number that's generated for that bag of powder or that pile of rock, and how does that all connect? So these are just some open questions, some room for opportunity in the future for this interconnectedness, the workflows, particularly as we expand our use and abuse of terms like geometallurgy and the whole mineralogy matters and the whole workflow. So I've been known to say this a lot. Many of you that have interacted with me, without the lab, really everything is just a guess. And which way do we put the dump truck, the haul truck, into this? Is it ore or is it waste? Yeah, that's certainly a real obvious example. Without that lab information, we're driving blind with which path to choose for the truck. Obviously, there's a lot more tied into this than just the lab is important. We need to make sure that we're actually talking about our sample needs. So we're talking about our samples in general. We tend to blame the lab for a lot of things. It's easy to blame a number once it's generated, but how good was the sample before it got to the lab? Is there room for opportunity improving our sampling, our sampling quality, and just our sample tracking and information, or reducing uncertainty associated with these samples as we go through this entire process? A topic that I'll talk about throughout the conversation today is actually this. Quality is a whole part of the entire ecosystem of data and sample tracking, and this information about quality, not just the number produced, but the quality associated with the number that's produced, and perhaps some of the uncertainty of the information along the way, like sampling. These are all really important parameters, and can't be stressed enough. I will talk about the silos, and we as companies talk a good talk about trying to break down these silos. In general, I think we're not very good at that. We still, as humans, tend to circle ourselves in our silos of comfort, and we still create these silos, these barriers to interconnectedness and communication across these parts of the ecosystem. So, a couple of important themes here. Yes, this interconnectedness of the workflow is important. The labs do contribute an important piece to many of the aspects of the workflow, but there's other fundamental things that we tend to forget. Treating just bags of powders or barcodes of samples as it's just a barcode, or it's just a bag, but the geology or the mineralogy of that sample. Maybe the geologists actually possess a great deal of information from their eyeballs, their sensors, and their hand lens. They know the mineralogy has changed. Would that be useful for the lab to know that they've gotten into a new ore zone that has some new challenges for the methods the lab is currently using? Are there some mineralogical difficulties in processing that affect the lab, but also then affect the mill? How do we communicate that information across departments and across silos? That's some of what we can improve using things like software solutions and things like that. Obviously, these results are tied to big money. Is it ore? Is it waste? Can we improve the processing, the recovery of these? Are there tidbits of information in the sample, in the data, in the laboratory and sample information that can tell us something that the rock is screaming at us to try to tell us there's something going on? But how do we actually communicate that data and actually utilize it effectively? Those are some of the topics that we still have lots to improve on. Integration of stakeholders. I can't stress this enough. A simple conversation with the lab, rather than the "where's my data?" or this data is no good. Maybe we can have some proactive conversations instead of reactive conversations with regards to, hey, I would like to see this kind of information be improved, or if I had this information, this would be helpful to us, or can I tell you something about the sample that will help you help me? And I think that's a really important. Related to some laboratory operations, standard operating procedures. Of course, data quality is paramount. A number isn't a number unless it has maybe some understanding of the uncertainties associated with it, some understanding of the quality control and quality assurance. Quality starts perhaps even before the sample is collected. How was the experimental design of the sample collection actually conducted? What are the intentions of the sample collection, and are they being sampled in an appropriate way that's relevant to the methods? Those are some of the questions that we need to ask at the beginning. Again, it goes back to maybe some planning and some communication. Obviously, the errors, the uncertainty doesn't get smaller as the process goes along. While we tend to focus on quality in the lab, and some of these uncertainties that we're generating today in the laboratory are so small because of improvements in procedures and quality control. that the quality, the uncertainty or uncertainty budget of these samples in the lab may now actually be smaller, significantly much smaller than the rest of the uncertainty in the entire equation of the sampling process, all the way through processing and into the answer, to the model, the geological resource model. So while it is easy to focus on the lab, maybe we also need to focus on some of the other areas where uncertainty does apply in this ecosystem. What are the expectations? Is is it just an ore control decision on yes, we're saying whether it's ore or waste. What are we trying to use the numbers for? Obviously, ore control decisions are incredibly important economically and financially. And where are we going, especially with all of the excitement that's in the minerals resources community today, with increased needs and increased prices? We can actually chase lower values. When we've originally set up the laboratory methods, some of the grades that we were chasing were significantly higher. Well, now the expectation is, because prices are high for some of these commodities, we need to chase lower and lower values. Are we actually capable of making good decisions at lower cutoff grades? Is the laboratory capable of doing that? Is the instrumentation and methodology capable of doing that? And that's where the communication on expectations and vision certainly play a really important role. Of course, are tied to the bottom line, and labs are seen as a cost. Yes, it does cost money to run a lab. It actually is not free, and we need to actually be mindful of this, of course. But the value that's brought through these decisions that are made from the laboratory data actually are very much tied to producing the value, producing the product or the doré, or the concentrate. So yes, the labs are a cost center, but they are absolutely critical to the profit and value created by exploration programs, site labs, metallurgy labs, and others. Something that I think that we as a community tend to forget. We always are in a hurry, so we tend to forget that we can actually ask our colleagues and our commercial labs, our providers of information. We can actually ask them questions, and oftentimes they enjoy getting asked questions, making them be recognized as actually being useful. Many of these labs are actually more experts on the samples than maybe some of the people submitting the samples themselves, because they see so many different challenges. So these labs, both site labs and commercial labs, really are experts at answering questions about proper methodology and proper data treatment, and even some variation over time with the samples. So I think it's important that we remember that these labs are a great resource. There's huge opportunities to improve efficiencies in the workflow, and particularly on the data side. And I think that's really important to keep in mind, especially as we develop new methods, new challenges, critical metals, or whatever we call them these days, actually are expanding the list of elements that we need to analyze for. And that represents new challenges for the lab, but new opportunities for the customers as well. We're always at the mercy of these big picture decisions, and the lab tends to get forgotten in the planning process. So let's try to inject the lab into the conversation as early as possible, and we can actually go ahead and improve this by just good communication and good planning. Something related to obviously the portfolio of what Datamine offers is, as Alex mentioned, two products in the laboratory software portfolio that they offer is laboratory information management systems. I've seen many examples of LIMS in various forms in a variety of labs that I've been exposed to throughout my career. I have a lot of experience on how to implement a LIMS. I have a lot of experience on how not to implement or design or support or use a LIMS in these variety of situations. we have a lot of challenges with regards to supporting these limbs. And one of the questions that I've been exposed to throughout my career is, well, geez, I don't need to spend any money on this limbs. I could just make it myself, or I've got a guy down the hall that is expert at making wonderful spreadsheets. So do I actually need to sink the money into an off-the-shelf limbs? We've seen numerous examples of really great homemade limbs, and then the person involved in making that limbs moves on, or worse, and ultimately the support of that custom limbs may be something that's very difficult to keep up with once the person that knew all the secrets of how to modify that limbs, especially homemade limbs. I think those are some challenges with regards to that. Yes, it may be customizable, but it may be customized beyond repair, and no one may be able to service that in the future. So these are the questions that the labs need to ask themselves when approaching this question of upgrading a limbs. Should I upgrade the limbs using a commercial off-the-shelf product, or should I try to make it myself? And these are really important questions. If it's a research lab and there's only one person in the lab, then maybe the customized homemade version is the right approach. But for commercial labs, mining site labs, we don't have time to really curse at the limbs, and we need to make sure we can use the product. So these are some questions that myself and others here on the call can happily answer, some experience related questions, but give labs some guidance with regards to how to best tackle a project like this. Unfortunately, in the greater community of laboratories, geology is actually quite a small percentage of the market sector. And when you start Googling laboratory information management systems, vast majority of them are developed for other areas. So if you take a commercial off-the-shelf product that's designed for pharma, or for a very different sample workflow, it may not be appropriate for the types of samples that we use, or the types of questions that we ask. The export of data for the mining workflow may be different than how it gets used in a regulatory, pharmaceutical, or environmental lab. And so these are some important questions when thinking about upgrading a limbs. But thinking about upgrading a limbs, that's actually quite a novel concept. In many cases, myself, I go out and support a lab that has some methods development questions, and I interact with their software system, and they have a limbs that hasn't been upgraded, since Windows 2003 or something like that, or they're using some antiquated software that really hasn't seen any love over the last 10 years. We tend to forget that these software products, maybe we put a lot of money into it at the time. We tend to forget that there's reasons for doing a tune-up or a health check for the software. Sometimes the lab folks may be just used to the quirks. They've put up with these quirks of the laboratory software for the last 10 years, and this is just how it is. But is there a better way? Is there something we can do with a small change, with an upgrade, or an improvement, or just a health check for the laboratory software? Now, this is true not just for laboratory software. This is true for the methods themselves. So this is true for the entire workflow of a laboratory. But often we encounter the limbs is not the technician or operator or chemist's favorite part of their day. They're generating great amount of data and great quality data, but they have to hammer the limbs to get it to cooperate with both customer information, with their laboratory information, and with their export to the outputs. So there's lots of opportunity here that I think are untapped and need to be leveraged going forward. So I think that's another area of opportunity. Change is hard. We know that's true. Changing the workflow, changing just changing the methodology or the thinking of the workflow as we try to bust down these silos. It might actually improve things in the long run, but along the way, it actually introduces some changes. And I think that's something that as humans, well, yeah, it might be better, but I don't want to do it because change is hard. Um, Here in the picture, we have some examples. We've improved technology since the early spectrometers, the early atomic absorption spectrometers. Um, in some cases, fit for purpose. The old AA may actually still be useful, but as we chase lower and lower grades or lower and lower environmental regulations, we need new instrumentation. This seems like an obvious upgrade, and in fact, one that labs have been pretty supportive of. I have a new widget that's going to make my analytical data or my workflow better, so I'll change to this from the AA to the ICP OES or maybe to an ICP MS, and those are changes that we have adopted within the geochemistry community. Then there's other changes that are actually much harder. We've got 3,000 years of fire assay experience, 100 years of fire assay as a recent analytical tool for gold analysis and precious metals. But changing from a conventional method to a new method, such as shown here as photon assay, these are some exciting technology developments that may change the entire workflow of how we operate in the lab. And these are big changes, and they're difficult for humans to adapt to. But the improvements may way outweigh the temporary pain of a little bit of change in the workflow. But I will say that changing a LIMS is actually one of the most catastrophic to the humans of the laboratory of the customers, and that is a pretty big change and something that needs to be carefully planned for. It's yes, it may help IT or it may help budget in some cases, but if it completely destroys the morale and operations of the lab, then those are some things that we need to think about. Yes, it may be the best decision to change the LIMS, but we need to plan for it carefully. And there's a lot of help that those of us that have been through these experiences can provide in planning that process. So critical evaluation, just what do you need? What do you currently have? What are you currently missing? And then how are we going to do this in a change management approach that doesn't kill the humans? So what does this look like in the future? I think there's a lot of opportunity here to do smarter, better tracking. We see a lot of automation coming into the laboratory, sample prep automation, robotics, data automation. How do we actually implement that? Again, through careful planning and evaluation of what's needed for the lab. Sinking some money into the lab. The return on investment for improvements in the lab may be absolutely huge for the entire mining operation. That's something that I think that we need to revisit. I could give hours and hours of talks about all the things we do wrong on the sampling side, but with some of these developments, we're seeing recognition of improvements in sample tracking related to the analytical work or the metallurgical work. Better sample tracking are some of these big improvements that I see coming along. Integration of data across the silos. What does the metallurgy say? What does the geology say? What does the environmental management say? These are all important pieces of the sample information workflow, and having some software tools that actually integrate across those silos is actually super important. But better planning, optimization, health checks for your laboratory. These are some of the things that will help along the way. Because of regulatory and commercial requirements, we certainly do need to audit our laboratories at the highest level required, the highest level needed for the output, the good quality. But something that I feel is very important is an audit, maybe a checklist, maybe a check of, are you following your procedures? But is there a parallel evaluation that can actually inspect your lab for improvements in methodology that go beyond the audit or parallel to the audit. The audit may not catch some of these technological challenges. Maybe the procedure has some opportunity to be improved. Maybe you're following the procedure, but it isn't the best procedure that would apply for your customer samples. And that's where evaluation versus audit or review versus audit may be something to consider for your labs. Is it working? Your staff is a great resource for providing feedback on what does and doesn't work. What does the staff think? Are the customers getting what they want? This is a requirement, audit and regulatory requirement to make sure the customers are getting the responses they need, the changes they need, and the customers provide a great feedback of possible improvements. So I use the mental health phrase, are you okay? Checking in, not just with the humans, but also with the software. Is the software actually functioning in an okay fashion? Are we still running old techniques or old software? Is IT both presenting some new challenges with your current software, or have there been some improvements in how we can actually integrate things with the IT group, both at the commercial labs and as well as mine site labs? So there's some opportunity there for checking in on the software. Would updating the process, where are the biggest areas that you see are bottlenecks, and what can we do to help that? Those are some of the things that we can jump on and help you. Consult your friendly neighborhood lab nerd. There's a number of resources out there that we're usually so busy just keeping our head above water with the sample workflow that we forget to take the time to ask for help. And I think that's something that is a real opportunity for improvement as well. So I'm just kind of wrapping up a little bit of my rant about cheerleading for the labs are important. Cheerleading for there's lots of software and methodology improvements out there, and I think that forums like this are a great way to convey information, both from the commercial side, from the consultant side, and kudos to those of you that take the time to do that. But look out for your friends that your colleagues that aren't aware of some of the information that's coming along, these improvements that are possible. When you see a bottleneck, think about, is there some way to reach out and improve those?